Chapter 2 is all about functions, and 2.1 examines what is a function. A function is a rule that describes how one quantity depends on another. So a real-life example would be the distance traveled by a moving object is a function of time. Do you know of other examples? A function f is a rule that assigns to each element x in a set A exactly one element, called f of x, in a set B. So we have f of x, or f at x. It means the value of f at x. So you will have set A, which is the domain of the function, and then the range of f is the set of all possible values of f of x, as x varies throughout the domain. So you'll have f of x where x is in set A. So let's start with the squaring function. We have f of x equals x squared. And we want to evaluate f of 4, f of negative 4, and f of root 8. Now you notice on these, where there was an x, there's now a number. So we're looking at f of 4. So wherever we see an x, we plug in a 4. So it becomes f of 4 equals 4 squared. So f of 4 equals 16. For f of x equals x squared, and we're evaluating f at negative 4, we plug in negative 4 and square it. So f of negative 4 is also 16. Lastly, we have f of x equals x squared, and we're evaluating f of root 8. So we plug in root 8 for x and square it, and we all know that a square and square root cancel. So we get f of root 8 to equal 8. We are now going to find the domain and range of f. The domain is the x values. Now we plugged in positive, negative roots, so your domain of f is the set all real numbers. The range is what we get out when we evaluate. And we will only get positives out because we are squaring x. We have x squared will always be greater than or equal to 0. So if we were to put this in set builder notation, we would have y, where y is greater than or equal to 0. And if you were to use interval notation, this becomes from 0 to positive infinity. We're now going to evaluate the function f of x equals 2x squared minus 6x plus 17 when f is negative 2, 0, and 1/2. So let's start at f of negative 2. Wherever we see an x, we're going to plug in a negative 2. So it goes 2 times negative 2 squared minus 6 times negative 2 plus 17. So So negative 2 squared is 4, so 2 times 4, that'll be plus 12 plus 17, so we get 8 plus 12 plus 17, and that goes to 37. Now I'm going to work out f of 0. So wherever we've seen x, we plug in 0. 2 times 0 squared minus 6 times 0 plus 17. So f of 0, 0 squared is 0 and 2 times 0 is 0. Negative 6 times 0 is 0. So f of 0 is 17. And now, finally, we're going to work out f of 1/2. So it goes 2 times 1/2 squared minus 6 times 1/2 plus 17. 1/2 squared is 1/4. So 2 times 1/4 goes to 1/2. Minus 6 times 1/2, which is 3, plus 17. So 2 minus 1/2 minus 3. Let's go ahead and change that to a decimal. It will make it a lot easier. 1/2 is now 0.5. 0.5 minus 3, that's negative 2.5 plus 17. So we get f of 1/2 becomes 14.5. So now we're going to talk about piecewise notation. It's where we have two different rules depending on where x falls. So we have f of x equals 2 minus x if x is less than 1. And we have f of x equals x squared if x is greater than or equal to 1. We're not going to worry about graphing this right now. We're just going to evaluate at negative 2, 0, 1, and 2. We'll get to graphing later. So when x is negative 2, that's less than 1. So we're going to use f of x equals 2 minus x. So it becomes f of negative 2 equals 2 minus negative 2. That turns to 4. Now we're looking at f of 0, and 0 is less than 1, so we're still using f of x equals 2 minus x, so f of 0 goes to 2 minus 0, which is 2. For f of 1, we're going to use where 1 is greater than or equal to 1, so we're going to use f of x equals x squared. F of 1 equals 1 squared, which is 1. And f of 2, we know 2 is greater than or equal to 1, so we're still using f of x equals x squared. So f of 2 equals 2 squared, which is 4. We're now going to work with evaluating a function, and instead of x, it's at another variable. So let's begin by evaluating f of x equals 2x squared plus 3x minus 1 at f of a. So instead of an x, we are substituting in a. So it becomes 2a squared plus 3a minus 1. There's no work to be done, nothing can be simplified, and we're not going to worry about factoring. For f of negative a, wherever we see x, we are plugging in negative a. So it goes 2 times negative a squared plus 3 times negative a minus 1. Negative a squared just goes to a squared. And 3 times negative a becomes a negative 3a minus 1. Now we're going to plug in a plus h for x. So this one will have a little bit more work to do. So it goes 2 times a plus h, quantity squared, plus 3 times a plus h, minus 1. So we need to expand a plus h quantity squared into a plus h times a plus h. I'm going to have to FOIL. So it goes to 2 times a squared plus 2ah plus h squared. And now we distribute the outside 2. So we get 2a squared plus 4ah plus 2h squared. Okay, now we need to take care of the 3 times 2a plus h and distribute the 3. We get plus 3a plus 3h. And then bring down the minus 1. We're checking for any like terms. It says a squared, there's no others. There's no other ah's, no other h squared, nor a's, nor h's. So this is simplified. Okay, now we are going to take care of the quantity f of a plus h minus f of a all over h. Well, we already know f of a plus h, and we already know f of a. So now we're just going to substitute it all in. So we get 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1. Now we're going to subtract f of a, and we have f of a from up here. 2a squared plus 3a minus 1. And this is all over h. So, next, let's distribute the negative to the second set of parentheses. So it becomes negative 2a squared minus 3a plus 1. And let's collect like terms. So we have 2a squared and a negative 2a squared. Those are known to cancel. We have a positive 3a and a negative 3a, so those cancel. And we have a negative 1 plus 1, so those will cancel. So we are left with 4ah plus 2h squared plus 3h all over h. Now every term in the numerator has an h, so we can cancel it out from each term, and it cancels out with the denominator. So we get 4a plus 2h plus 3.